Overfitting in machine learning is a common yet often overlooked phenomenon. This is due to the fact that it is not as visible or obvious as other problems that can arise in the training phase of an algorithm. The most common understanding of overfitting is a situation in which the algorithm memorizes training data instead of truly learning from it. To understand it more clearly, let's discuss what happens during the training phase of an algorithm. During the training phase, the algorithm uses sample data to learn how to create models for future input data. The algorithm is designed to create models that are able to accurately represent the relationships between the sample data and the expected output. In an ideal situation, the algorithm would be able to learn patterns from the sample data and be able to accurately predict the expected output from new input data. However, when overfitting occurs, the algorithm creates overly complex models that start to overfit the sample data. This means that the models start to match the existing sample data too closely, resulting in the models being able to make accurate predictions on the sample data, but not on future unseen data. There are a few ways of detecting overfitting in a machine learning algorithm. One method is to compare the performance of an algorithm on training data versus unseen data. If the algorithm has a significantly higher accuracy rate on the training data than on unseen data, then it is likely that overfitting has occurred. A second method is to look at the complexity of the algorithm's models. If the models are overly complex, then this could also be an indication of overfitting. To prevent overfitting from occurring, regularization techniques can be used to limit the complexity of the models created. Regularization techniques help to keep the models more general and thus more likely to correctly represent unseen data. Data augmentation, which involves using different methods to slightly alter the data on which the algorithm is trained, can also help to reduce the likelihood of overfitting. Overall, overfitting is an important phenomenon that should not be overlooked in machine learning. Many algorithms that seem to be performing well can have hidden problems due to overfitting, and it is important to be aware of this phenomenon and take steps to ensure that it does not occur. Using regularization and data augmentation techniques can help to ensure that the algorithm is able to learn the right patterns and generalize well to new unseen data.